On page 640, we've got an example where we're asked to calculate the volume of a solid of revolution. So let's take a look at that. All right, so here we've got this region that is bounded by the graph of y equals x squared, which is the parabola, and y equals x plus 2, which is the straight line. And so the first question says we want to rotate that around the x-axis. So what kind of shape are we going to get when we get that? It's going to be kind of weird looking, but we don't need to worry too much about that. First thing we want to do is we want to think about the two different shapes, the outside shape and the inside shape. So for the outside shape, we're thinking about a box that looks something like that. All right, and so that's rotating around. And so that volume, using the formula we had from earlier in the thing, is we've got pi times the definite integral of the line is x plus 2. And because we're making a cylinder out of it, we've got to square this, dx. Okay, and what are the bounds of integration for this? What's the left and right hand side of this shape? Well, over here our x value is -1, and over here our x value is 2. So we've got -1 and 2 there. Okay, so right now I'll just express it like this. And now let's think about the inside shape. So V2 is the solid made by the parabola. And so this is going to be something that's going to look like this. So this is going to wind up being a hole inside the solid that we make. And so its volume is going to be the same basic formula, -1 to 2. This time, the function is x squared, but we still need to square it again, times dx. Okay? And then once we calculate these two values, what are we going to do to them in order to find the volume of the solid that comes out of it? Well, we're going to take our big shape, which is V1, and we're going to subtract out our smaller shape, which is V2. Okay, so let me do this. Let me switch over. You can do this by paper, finding those antiderivatives. X plus 2 squared, you would just multiply that out, and you would have a simple polynomial that you could find an antiderivative of without any trouble. But I decided to go to my Inspire and have it do the work. So this first integral was equal to 21. And notice that I left the pi out of it. So this would be 21 pi. And the second one would be 6.6. That is the volume of the parabola. So that's 6.6 pi. And subtracting the two of them, we come up with a total volume for that solid, including taking the hole out, of 14.4 pi. Okay, so that I just copied that into my sheet. And so there is the work that I did there. So just calculating these three things on the calculator. All right, in the next video, we'll take a look at these two side problems where we're rotating around a line that is parallel to the x-axis, but is not the x-axis itself. And we'll see how that changes the formula.